Day one, guys. Oh, font size is very big. Let me decrease that. Can decrease like that also. Oh. Yeah, see, guys, these are the components we learn day one basic networking. Okay, what are those? First one is called network. And what do you mean by internetwork? What do you mean by networking? What do you mean by internetworking? Okay, network means collection of pieces connected together. All the pieces should be in the same network. Clear now? That is called network. If you want to send any data from one PC to another PC within the network, that is called networking. The communication, the sharing process. Okay, we are sharing the resources, printer, scanner, files, so and so. All these things within the network. That is called what? Networking. King means there is a sharing process or communication process. Okay, networking means there is a sharing or a communication process will happen in the same network. Inter networking means the communication and sharing process will happen from one network to another network. Okay, how it is possible to share the resources from one network to another network without connectivity? No, right? With connectivity, how to connect from one network to another network by means of router. If you want to connect the PCs within the network, what device is required? Switch is enough. Switch for connecting PCs in the same network, and router is a device to connect from one network to another network. Clear now? Internet networking means what? The communication and sharing process will happen from one network to another network. Okay. And also, what are the requirements, minimum requirements to design the network? If you want to form the network, what are the requirements? PC should be required, cable should be required, switch also required, server required, clients are required. We need to install the server OS or server side and client OS or client side. Then we need to do, there is a proper connectivity, we need to assign the IP address, correct now? Then we'll do the sharing process, okay? And also without LAN card, we can't able to get the LAN port. We have a LAN port here now. For every laptop has a LAN port now. For that only we will connect that cable. This is called which cable? LAN cable or UTP cable. Under UTP, how many categories will be there? Category 1, 2, 1, 2, 3, 4, 5, 5 is 6, 6, 8, 7, 8 like that. Okay. But for every cable is a some limitation to carry the data or the speed of 10 Mbps or 20 or 50 or 100. See, category 5 supports 100 Mbps, category 5E supports 1 Gbps, category 6 also. There is some difference will be there between category 6 and category 5. There is a gauge. Okay, category 5E as a less gauge, that means this cable. Category 6, yeah, please. 6 as a more gauge, means very thicker cable. This is what category 5E only. Okay, category 5E only. We don't have any category 6 cables. That is like a thick one. Okay, I'll show you here. Category 6, the gauge will be more, that means little bit thicker cable. Cat UTP Cat 6. UTP Cat 6 cable. Check it over there. And this is called category 6 cable, guys. Somewhat thicker. That means the gauge will be higher gauge. In your organization, you guys are connected only category 6 only. Yeah, please. Category 6 only, not category 5E. Category 5E has a very less gauge. Okay. This is a category 6. This is also okay. See, the gauge is very stronger cable. Clear now? And also that cable as a one side is connector. This connector is called what? RJ45. How many pins will be there? That means internally how many wires will be there? 8 wires now. Check it over there. How many wires will be there? Let me see here. Can you see here how many wires are there? 4 pairs. That means 8 wires. Two wires are twisted to overcome from electromagnetic induction and radio frequency. Okay, that's why they're twisted. Okay. And also connectors are of 2 types. One is this is called what RJ45, and we have a RJ11 also. Let me type that also. RJ 11 connected, guys. And this as a only 4 pins. This is for telephonic purpose. This is for what? Telephonic. What about the RJ 45? For what purpose? LAN purpose. It has a how many pins? 8 pins. This will be used in the LAN purpose. Okay. And that is a difference, guys. And also what the switch? Let me show the switch also. These are the switches, guys. Actually, I told now 2960 as a each port is a gig ports. Gigabit Ethernet port. Now, what is the speed of the gigabit Ethernet port? 1000 Mbps or 1 Gbps. What about the Ethernet 10 Mbps only? Ethernet port means that as a capability 10 Mbps. What about the fast Ethernet? 10 into 10 and 100 Mbps. What about the gigabit Ethernet? 100 into 10 1000 Mbps or 1 Gbps. Okay, that's the different the port variation. And here is we have 37 series is there that as a all ports are gig ports, and also we have a 3550 is there 3550 these things, this one, not this one, this is a 3560, and we have a 3550 also here, 3550 3560, and this is called 3750. Clear now? Okay, there are multi ports are there, no? That means that is called switch. That is called what? Switch means why those many ports are there for connecting your PCs. Okay, how many ports are available? That many PCs I can connect. Okay, clear now? Without LAN card, you can't get that LAN port, then you can't connect the cable. And also, LAN card will provide the two addresses. LAN card will provide the two addresses. Let me write down that also. 1 second, let me connect the writing pen. Actually. LAN card has two addresses. See, in your mobile also there are two addresses, guys. What are those? One is called IME number, one is called what? Phone number. No? Can you change the IME number? No, why? That has been banned by manufacturer. Who is the owner for that mobile? No, that guy has been banned that address. That is called IME number. For what purpose that IME number is there? To track the device. No, we can able to trace the device. If your mobile is lost, what you will do? You will give the complaint with the mobile number. IME number is mandatory. No, same like that. That means that is called physical address. We can't change. Which address we can't change? Physical address we can't change. What about the phone number? Can we change or not? We can change by inserting some other SIM. That means whichever the address we can change, that address name is called what? Logical address. Physical address we can't change. Logical address we can change. Okay. Here also there are two addresses will be there, guys, for your LAN card. As a two addresses. One is called a physical address and one is called logical address. It has a two addresses. One is called what? Physical. One is called logical. Physical address is called MAC address. What about the logical address is called what? IP. MAC means media access controller address. IP means internet protocol address. This address we can't change. Okay, how to check the MAC address and how to check the IP address for the device? We need to first go to the CMD. Here we need to type the IP config. Clear now? Enter. Can you see here? This is called your MAC address. Where is my wireless adapter? Yes, here. This is called my IPv4. Once again. There are 12 hexadecimal number will be there. Let me type get MAC. See, this is called my MAC address, guys. MAC address will be always in the form of hexadecimal that will be understood by human beings, but machines will understand only binary. Machines will understand only binary. Okay, that means each hexadecimal, hexa means what? So what do you mean by binary means? 0 or ones, no? 0 or 1. What about the decimal? 0 to? That means 10. No? Whatever the hexadecimal means, hexadecimal means 0 to 9. After that 10 will be there. Not 10 is nothing but a decimal in hexadecimal A. In hexadecimal A. And next is 11, 12, 13, 14 and 15. 15 is decimal in hexadecimal F. Clear now? 1 hexadecimal equal to 4 binaries. Okay, 4 hexadecimal equal to 4 binaries. How we are getting that? That is called 1010. For F, decimal number is binary number is 1111. How we are getting these values? My decimal number is 10. My hexadecimal number is A. What is the binary? If you don't know, divide by 2. 2 5 jars, 10 remainder 0. 2 2 jars, 4 remainder 1. 2 1 jars, 2 remainder 0. Okay, what are the reminders you are getting now? Write down from bottom to top. 10 10. Clear now? This is all about my binary number. That means one hexa number equal to how many binaries? 4 binaries. That means how many hexa numbers are there? There are 12 hexa numbers are there. Check it over there. 2, 4, total 12 hexa numbers are there. That means 12 hexa numbers are there. Each hexa number equal to how many binaries? 4. You will get what? 48 bit in binary. In binary 48 bits. In hexadecimal 12 hexadecimal number will be there. Clear now? In that, this is not total your MAC address. See, this is my mobile number now. 950205464. This is not complete my mobile number. This is for identification of the vendor. This is by seeing this number, 5 numbers, we can understand this is from Airtel and this is my mobile number. Clear now? Same like that here also. By seeing this complete information, this is total your MAC address now. Up to here, that is for identification of who is the owner for the company. That means who designed this LAN card. That means manufacturer ID. That manufacturer company has given one MAC address for my LAN card. Okay, this is called vendor ID. This is called device ID. For that LAN card, that guy has given one MAC address. That is called this one. This is my MAC address only. This is not complete. This is for manufacturer ID. For identification of the manufacturer ID. Okay, suppose one A company is there. For that A company, he need to manufacture some LAN cards. First, he will take the 6 hexa numbers from one organization that is called IANA. They will provide the IP address also. They will provide this port also for identification of this A company. Suppose this guy, this company has bought some number for identification of the company that is called 000, sorry, 00, 00. This is all about the identification of the company. That company will manufacture LAN card number 1. LAN card number 1. For that MAC address is this 000001. Clear? And they want to manufacture one more LAN card number 2. Then what will happen? This number will not change. That is for identification of A company 00. Then what about this? They will assign one number for LAN card 2 that is called 000002, right? Like that. Okay, that means here is total how many bits are there? 48 bits. Okay, in that 24 bits for the identification of the organization and remaining 24 bits for the generating LAN cards. That means 2 power 24. That means almost 1,67,77,216. This many LAN cards that company can able to manufacture. Clear now? They want to manufacture one crore 67 lakhs. They need to purchase one more number. This number, by using this number, they can manufacture up to how many LAN cards? 1 crore 67 lakhs 77,216. 2 power 24 equal to that many. Suppose they want to manufacture remaining maybe 10 lakhs or 20 lakhs or 1 crore. They need to purchase one more number from IANA. That number should be like this 000001. Correct now? By using this number again, they can generate what? 1 crore. Clear now? This is all about the way how they will manufacture the LAN cards. Clear now? Okay, this is called what? OUI field OUI, organizational unique identifier. This is called vendor ID. That means that company, okay, that company, a company has assigned one ID for my LAN card. That is called vendor ID. Okay, now OU means organizational unique ID. Okay, what about this vendor ID means? My LAN card has a MAC address, unique MAC address. That is called this one only. This is what? Identification of the company. Clear now? That means MAC address has been divided into two parts. First one is called what? OUI field, organizational unique identifier. What is that? Organizational unique identifier. Remaining what? Vendor ID. Clear now? Any question, guys? That means totally you need to remember only one thing. In binary, 48 bits. In hexadecimal, 12 hexadecimal characters will be. Clear now?
LAN cards are available for all electronic devices.
Yeah.
Only for
No. For laptops and desktops and servers.
mobiles.
How mobile is available? Any LAN card is LAN port is there?
Charging port is not LAN.
No. Clear now? Any question? Okay. That you need to remember, guys. Okay. MAC address will be like that. We need to check. How to check the?
But I have seen in mobile settings somewhere. MAC number.
No, MAC address will be there, but no LAN port. You can't get the LAN port. MAC address will be there. For every device, MAC address mandatory. What you are asking question?
LAN card.
You are asking LAN card. No LAN card. MAC address will be there. For every device, MAC address should be required. Okay. Clear now? How to check the IP address, guys? Okay. Command is ipconfig space / all. See, this is my MAC address. Just now we saw. And what about this? Your IP. See, for every device has this many entries, guys. That you need to remember. Okay. That you need to remember. What are those? Physical address means MAC address and IP version 4, subnet mask and default gateway. Clear now? And DNS entries. Okay. IP, mask, default gateway and DNS. This is called preferred DNS. This is called alternate DNS. Okay, write down all these entries. Just only names only write down. Okay, MAC address, IP address, subnet mask, default gateway, preferred DNS, alternate DNS. These 5 names you need to remember. We will discuss what is this subnet mask, what is this default gateway, preferred DNS, alternate. Okay, but you need to remember the at least names. At least what names you need to remember. Okay. Can you see now? Just only at least names you need to remember. Okay. Names you need to remember. Physical address means MAC address, IP address, subnet mask, default gateway, and preferred DNS and alternate DNS is required. These things you need to remember. These things will be there for every device. Okay. For laptops and desktops and servers. For every device has this many parameters. Okay. Don't write down the MAC address. Okay. Only don't write this one. This one is not required. This IP addresses are not required. Only write down the names only. I'm telling what? Only names only. For every device is a IP address, subnet mask, default gateway, and preferred DNS and alternate DNS. Preferred DNS and alternate DNS. MAC address will be 12 hexadecimal number. Okay. In hexadecimal. In binary, there are 48 bits. In binary, there are 48 bits. Machines will understand binary, but we will understand either decimal or hexadecimal. Okay. But IP address is okay. How many bits? That is called 32 bits. Bit means binary. We can't understand. That's why they converted into decimal. See 192, 168, 0 dot something. This is called decimal format now. Okay, they put the dot. That's why that is called what? Dotted decimal notation. What is that? IP address will be here dotted decimal format. That means we can understand either decimal or hexadecimal only. MAC address in the form of hexadecimal, IP address in the form of decimal only. That dotted decimal notation format. Clear now? Written? Right. We will discuss about the IP address, version 1, version 4, version 6, all these things later. Okay. Right. Let me close this. See guys, once you design the network, you have to check these parameters. CIA. C means confidentiality. C means what? Confidentiality. What about I means integrity, and A means availability. Confidentiality means communication is being happen now from client to the server. That communication is secure or not. Okay, secure or not. That we need to check. And also integrities. Who can able to access our network resources means servers. Only internal guys, not for the external guys. That we need to check. And also availability. Whatever the servers you are accessing, those servers are available or not. Okay, in some organization, always for every week there is a downtime, half an hour, 1 hour, 2 hours, sometimes one day also. That is good? No, right? That's not good, no? What we need to do? There is a frequent the downtime will occur. Then what we have to do? We have to host the servers in the cloud. We have to host the servers in the cloud. What are the cloud providers? AWS, Azure, and Google Cloud. We need to host the servers in the Google Cloud or Azure Cloud or AWS Cloud. Which one is more famous nowadays? More demand? AWS. Okay, Amazon Web Services. Okay, Azure also somewhat good. Okay, these are the cloud providers. We need to host our servers in the cloud only. Okay, maybe 10 servers or 15 or 20. How many servers are there in the organization? All the servers we need to host in the cloud. It will take less time also. Okay, we can able to host all the servers, okay, within the 1 hour, within the minutes only. What about in the organization? If you want to put the 20 servers or 25 servers, it may take sometimes like one month also. We need to purchase all the devices, hardware devices. We need to hire the server admin guys. Okay, and they will do the configuration, that one, this one. It will take 1 month easily. Okay, and they want to check the productivity, no, and also production also up and running or not. It will take easily, okay, time. And also we need to hire those guys. Okay, and also physical environment is required, some AC required, electricity maintenance is required. Everything should be proper, then only your servers will be run always up and running, or else sometime downtime will occur. This is totally risky process. Now that's why what I will do, I will host my servers in the AWS cloud. That there also physical environment will be there. It's not like a cloud. Okay, they have their own physical environment. Okay, with proper particular AC and electricity, and also there are engineers will be there, server engineers, and also network engineers, security engineers. All the guys will be there. Okay, all are the reliable guys will be there. They will take care about everything. That's why there is no downtime over there. Okay, maximum downtime will not occur. Okay, always up and running. Okay, servers will be available 100% over there. Okay, clear now guys? This is all about the reliability factors. We need to check what are the things. First we need to check the confidentiality, integrity, and availability. Clear now? Once you design the network, now we'll discuss about the types of networks. See, these are the types of networks: LAN, CAN, MAN, WAN. See there, what do you mean by LAN? We have an office within the building, that is called one LAN. Multiple buildings, if you want to connect by using fiber optic cable, that is called CAN within the campus. If you want to connect the branches within the city, that is called MAN. There also will use fiber optic cables only. For WAN means we have branches across the world. That comes under WAN. Clear now? LAN means building, CAN means multiple buildings, MAN means branches within the city. If you want to connect, we need to use fiber optic cables. WAN also for connecting multiple branches across the world by using fiber optic only. Under fiber optic, there are two cables will be there. One is called multi-mode and one is called single mode. One is called what? Multi-mode, and one is called what? Single mode. Multi-mode supports only 2 kilometer distance. Multi-mode fiber optic. Single mode support 40 kilometer distance. Multi-mode fiber optic supports how many kilometers? 2 kilometers. If you want to connect the blocks within the campus, one block is in one building. Okay, within the campus, building to building distance will be more than like maybe 200 meters or 500 meters. That's all, no? Or else maybe maximum 1 kilometer. More than that? No, right? Okay, that means if you want to connect the building to building, okay, within the campus, there is a distance between the building to building, maximum 500 meters or 1 kilometer. Then simply we'll go with the multi-mode fiber optic. MMF means what? Multi-mode fiber optic will support the distance will be 2 kilometer. Clear now? If you want to connect the branches within the city from here to Marthalli, there is a distance more than 2 kilometer. Na? Then what cable is required? Multi-mode doesn't support more than 2 kilometer distance. We'll go with the single mode fiber optic. It supports up to 40 kilometer. Okay. Suppose we have branches. One is here, one is in Hyderabad. Only 40 kilometer distance? No, right? That time we'll use the connectors. There are some connectors will be there in the fiber optic. Okay, that connectors we'll use. Okay. We'll see the connectors in the copper media and we'll see the connectors in the fiber optic. We'll see the connectors in the like we have a RJ45 connectors are there, RJ11 is there in the UTP cable. What are the connectors in the coaxial cable? That we'll see in the next slide. Types of cables. See there we have a cables, guys. Under copper media there are two cables. Dish TV cable, that is called black one, coaxial cable, and we have a UTP cables. UTP means this one. Okay, LAN cable or Ethernet cable. Okay. Now under fiber optic there are two cables, multi-mode fiber optic and single mode fiber optic. It supports up to 2 kilometer. What about this single mode? 40 kilometer. Clear? Now we'll see connectors under coaxial, okay, under UTP cables, under fiber optic. Connectors, types of connectors under UTP cable. This one, you know, for LAN purpose, RJ45. RJ means register jack. Okay. See, under coaxial cable, what are the connectors are they? These are the connectors. BNC and T connectors for LAN purpose, and for WAN purpose, N type and F type. Nowadays, we are getting the internet service portal. They will give the link via coaxial cable. No, that time they are given. They have a connectors like N type and F type for communication purpose or internet purpose. Okay. Not for the LAN purpose. For LAN purpose, BNC T connectors. But we are not using these connectors nowadays. This is totally outdated. Now we are using for LAN purpose RJ45. That too we are using for LAN purpose UTP cables only. No coaxial cables. We are not using. But in which scenario they are using these cables? In the year of 1983. That time we don't have any UTP cables. No, that time. That's why they are using for LAN purpose these cables. Connectors are these are the connectors. BNC means British Naval Connector. Okay. T connectors, but we don't have these connectors nowadays. We are not using this cable also for LAN purpose. That you need to remember. This cable only for WAN purpose only. Clear now? Under fiber optic, we have a connectors. These are the connectors. ST, SC, LC. ST means straight tip, SC means subscriber connector, and LC means lucent connector. Don't worry about these connectors. How to use, how to connect. You will only ISP guys only will come to know about this one. While working in the service portal, no, that time you will come to know about these connectors. Okay. Just only remember what are the connectors in the fiber optic: ST, SC, and LC. That's all. Okay, how to connect? Okay, that is not our duty. Okay. Clear, guys? Now write down these cables and connectors, and before that, yeah, write down this one for 5 minutes. Let me pause the record. Say the modes of communications: simplex, half duplex, and full duplex. Simplex means only listening. See, via remote, what I can do, whatever the button I will press now, the TV will listen. Correct now? Then any commands will come from TV to the remote? No, right? That means remote is telling TV should listen. Correct now? This is called example for simplex. That means only for listening. They can't able to give the reply. For 2 months, baby, what will happen? Whatever we are telling, simply listening only. Okay. 2S baby. Sometime reply will come, sometime won't reply. That is called what? Half duplex. That means two-way communication will happen, not continuously. Correct now? But in the full duplex means two-way communication will happen continuously. Mobile communication nowadays. Okay. All the guys can communicate no? Simultaneously. Okay. What about the example for half duplex? Walkie-talkie. Hub also. Okay. Walkie-talkie. One person is talking now at the time. Other person can't talk. This person will press the button, then that person can listen. Okay, that means one person will talk by using walkie-talkie at a time. Okay. Now here you need to understand, if you connected the pieces by using switch, right? There is one more device. If you want to connect the pieces, that device is called hub. Okay, there is a device also, switch also, hub also for connecting all these pieces. How many pieces? 4 pieces here also. Okay, I'm connected. We have ports will be there here. 1, 2, 3, 4. We are connected now by using cable. Now here also 1, 2, 3, 4. Okay. Now see, here is a MAC address is A, B. Simply I'm writing only one letter only. But actually how many letters will be there in hexadecimal? 12 hexadecimal numbers will be there. C, D. A, B, C, D. IP address is 1.1, 1.2, 1.3 and 1.4. 1.1, 1.2, 1.3 and 1.4. Now see guys, by using hub, okay, multi-users can't communicate because it works like a hub duplex. Whatever switch, it works like a full duplex. That means all the guys can communicate simultaneously, but here not. Only one guys. That means 1.1 is communicating with the 1.2. Once that communication is done, then only 1.3 can communicate with the 1.1. That means multi-users can't communicate by using hub. That means if you want to do the communication from one device to multi devices, okay, that is possible by using switch only. Clear now? 1.1 can communicate the 1.2. Okay, once this task is done, then only 1.1 can able to communicate the 1.3. That means via particular port, okay, either you can send data or you can receive data only. You can send or receive only, but two tasks not possible. Clear now? By using switch, what will happen? Via particular port, we can send also, we can receive also continuously. We can sending and receiving is possible. Not only from one device, from multiple devices I can receive. And also I can send the data to multiple guys also. Clear now? That means two-way communication will happen continuously. Not only two-way, multi-communication will happen by using switch. Here, only one guy is sending at a time. Okay, other guy should receive. Okay, that means if this port can send or receive only one job only. Clear now? It works with the half duplex, whatever switch, full duplex. That you need to remember. Okay. Up is all about the layer 1 device, switch is all about the layer 2 device. What are these layers? We'll discuss after 5 minutes. Okay. Now, this is clear, guys. Any doubt? Simplex means only listening. What about the half duplex means? Two-way communication will happen, not continuously. Example is walkie-talkie. Full duplex means nowadays all communications. Skype is there, Zoom is there, Webex is there. All are what? Works with a full duplex. Okay. Switch is a full duplex. It works with full duplex. So up is a, it works with half duplex. Clear now? Now types of communications: unicast, multicast, and broadcast. See, in the classroom there are 10 guys are there. If I will take the class in Telugu, suppose only one guy is there, Telugu guy. What about Kannada? Kannada, there are 5 guys are there. What about English? Everybody will understand. Suppose I will take the class in Telugu, only one guy will listen. Remaining guys can't understand. That is called one-to-one communication. What about I will take the class in Kannada? 5 guys will understand. That means one to group. Only these guys, Kannada guys. Correct now? What about that means called? That is called multicast. One to specific group. What about broadcast means? If you take the class in English, everybody will understand. Na? That is called one to everybody. One to all. One to one is called what? Unicast. One to group is called what? Multicast. 1 to all is called what? Broadcast. That you need to understand. Now, how we will do always? Broadcast. Always. We can't do the communication from this PC to this PC. Exactly, we can't do. I don't want to send the data from A to C and D. That is not possible. Where sending the data from A to B, what will happen? Unnecessary packet will go to the C also, D also. While coming reply time also, what will happen? Reply time from where to where? B to A now. Then what will happen? Once packet will come to the hub, I will forward to not only A, will forward to A also, C also, D also. That is called always broadcast. That is really good. I want to send the data from A to B only. I don't want to send to remaining guys. If one do the communication, one-to-one communication, to overcome this unnecessary broadcast, you need a device called what? Switch. Switch will do, okay, as per our requirement. I want to send the data from A to B. Only A to B communication will happen. I don't want to send to remaining guys, not required. That means if you are sending the data to all the guys, is there any security? Whatever the communication process is happening from year to year, remaining all the guys will receive, and maybe middle one attacker is there, he will come to know. Okay, and he will do what? Attacks. Correct now? That I want to prevent by using which device? Switch. Clear now? It will do first time only broadcast. Why it will do first time broadcast? That I will explain. And next time onwards only unicast. First time switch also will do broadcast. Because of if you want to send the data from 1.1 to 1.2, I know about 1.1 MAC address is there, but I don't know about the 1.2 MAC address. Because even I don't know about my laptop MAC address, how I know about the neighbor MAC address? Tell me. Is it possible? Correct or not? Okay. That means I know the IP address. How you know IP address? Because I am the network admin. I assign IP address for all the PCs. I know about all the IPs. We can remember. Can we remember MAC address 12 hexadecimal number? Even I can't remember if I am using my laptop from last 10 years. How I can remember the neighbor MAC address? Correct. I don't have any neighbor MAC address. Then what will happen? Before sending any data, you have to define these parameters. Source and destination IP and source and destination MAC address. Destination MAC address is question mark now. Correct or not? That's way to figure out the destination MAC address, to fetch the destination MAC address. For the purpose, I need to ask to everybody who is 1.2 here. It will go for everybody, and who will respond? Only 1.2 will respond. How is understanding whether I am asking about the give me your MAC address? That will be done by our protocol, address resolution protocol. Clear now? That protocol will send the request packet to everybody. Okay, I am sending to everybody in that who is 1.2, give me your MAC address. If you receive the, if everybody will receive the ARP request, in that ARP request, what I mentioned, destination MAC IP address what? 1.2 now, only that guy will receive, yes, I am the 1.2. Then you will see the, this is which packet, ARP packet, that means, oh, somebody is asking, that means ARP request I receive, that means somebody is asking about my MAC address. That means is MAC address. Then you will reply with the, yes, I am 1.2, my MAC address is so and so, take down. That is called B. Clear now? Once I know about the destination MAC address is B, then next time onwards what I will do? I will send the data from directly from A to B only. A to B only. How switch will forward directly from A to B? Because of via all the ports, via port number 1 A connected, via port number 2 B connected. Correct now? Via port number 1 A connected, via port number 2 B connected, via port number 3 C connected, via port number 4 D connected. Okay, it will maintain one database table that is called MAC table. In that, it will check source is A, destination is B. Packet will come. What is the destination? B now. B is available on port number 2, directly from port number 1 to port number 2 only. Directly from port number 1 to port number 2 only. It will not forward to remaining all the ports. Like that, we can overcome the unnecessary broadcast by using device called switch. That is not possible here because of it could not understand even IP address also, MAC address also. Clear now? Hub could not understand IP also, MAC also. But switch will understand which address? MAC address. MAC address. Here one thing you need to understand, IP address is layer 3 address. Whatever the MAC address is layer 2 address. Whatever layer 1 address, signals only or bits only. Clear now? Layer 1 devices are called hop, cable, repeater, these devices. Layer 2 device called switch. Layer 3 device called router or L3 switch. See, these devices will understand IP address, guys, because these are the L3 devices. What about L2 devices? Switch will understand only MAC address. L1 device means cables, hub. These devices will understand, cables will understand MAC address? No. It will forward only signals only via the cable. Signals are bits only. Clear now? This also write down. What are the layer 1 components, bits and signals? What devices? At layer 1 works, one repeat cable. At layer 2, the address is called MAC address. At layer 3, IP address. And what are the layer 2 device? Switch. Layer 3 device, router or L3 switch. Then we'll discuss about OSI after 2 minutes. Signals and bits works under layer 1. What are the device will understand these signals and bits? Hub and cables. Layer 2, at layer 2 what address works? MAC address. Which device will understand MAC address? Switches. L2 switches. L3 switches are there. They will understand IP address directly. Routers also will understand IP address. Because of routers and L3 switches works under layer 3. They could understand layer 3 address called IP address. Router and L3. Router supports only routing. L3 switches support routing and switching. L3 switch supports both routing and switching. And router supports only routing only.
This is L3.
L3, yeah. Okay, written, right. Now we'll discuss about the OSI. For discussing, let's I need to written, guys.
Yes.
Okay. On board this also I need to download. Let me download. This one is enough today. Can you see here, guys? OSI. OSI has been developed by ISO in the year of 1970. Okay. What happened before 1970? There is a question. Before 1970, okay, there is a see there are devices. There are two devices are there. One is from Dell, one more also Dell. Okay, same device now they can communicate. They can share the resources. Now scenarios change. One is Dell, one more is HP. They can communicate? No. Before 1970, because of every vendor, they have their own networking model for communicating their own device only. Okay, Dell as they have their own networking models for communicating Dell device only. HP also, they have their own networking model for communicating HP device only. But this model and this model both are same, not same. That means there is a compatibility issue. They could not able to communicate. Clear? That means you have to purchase all the device from same vendor only, same company only. Then only there should be some possibility, communication possibility. Correct or not? Is it really good? No, right? That's what I want to do. I need a common networking model that should support for any company device. To overcome this compatibility issue, what I want to do, I need a one common networking model that should support for any vendor device. Correct now? That open networking model is called OSI. Okay, who designed this one? Develop ISO. ISO means International Standardization for Organization in the year of 70. Clear now? This is the open networking model. Clear now? What this networking model will tell? It will tell how the communication process will happen from your laptop to your friend laptop. Your friend is there in the UK. You are sending and receiving the mails. There is some files you are downloading, uploading from internet. Correct now? Mail communication, web communication. Okay, file communication. How it will happen? Okay, web communication. The Google server is there in the UK or US. How the communication will happen from this end to that end? That communication process will explain. Okay, anyway, open networking model is there, but how it is working, that we have to learn. Clear now? This is an open networking model. What it will tell? It will tell, I will explain you how the communication process will happen from this end to UK. Your friend is there, you both are sending and receiving the mails. That communication process, I will explain. That communication process actually divided into 7 logical layers. That communication process divided into 7 logical layers. Clear now? Now write down this one. Any question? See, OSI will tell what? It will tell OSI is the process for end-to-end coming. That process only we are learning. That process has been, we are learning in 7 logical ways. 7 logical layers. The communication process from here to your friend laptop is that how the communication process will happen. That has been divided into 7 logical layers. What are those 7 logical layers? We'll see in the next slide. Application, presentation, section, all these things. Let me minimize. See, these are the 7 logical layers. What are those? These are application layer, presentation layer, section, transport, network, data link, and physical layer. These are the 7 logical. That total communication process has been divided into 7 logical layers. What will happen in each and every layer? There is some process. There is some process. What process? See, at layer 1, sorry, not layer 1, at layer 2, it will add the MAC address. At layer 3, it will add the IP address. At layer 4, it will add the TCP UDP. Clear now? We'll discuss all these things, okay? Now see guys, these are the layers, are the 7 layers. Out of all layers, which is the first layer? Layer 7 is called what? Application. Clear now? This is the physical layer. Data link layer is this. Layer 2, layer 3, layer 4 up to layer 7. Okay. Now what will happen each and every layer, that we'll discuss. You know about up to here. Under physical layer, what are the devices box? Cables, repeater, hub. These devices can understand only signals and bits only. Correct now? And at data link layer, which device box? Switch. They could understand only, this is called L2 switch. We'll understand L2 address. That is called what? MAC address. MAC address is called what? L2 address. Router is L3 device. L3 switch also L3. It could understand IP address. Clear now? Now firewall is all about the layer 4. It's not exactly layer 4, it's a multi-layer. It works under maximum all the layers. Okay, and it could understand only layer 4 components like a TCP and UDP. TCP means transmission control protocol, UDP means user datagram protocol. These are the transport protocols. If you want to move from this street to neighbor street, what you will do? You will book the bus from here to next street. Bus is required. What is required? Only 100 meter is there. Walk is enough now. That is your transport. If you want to go from here to your PG, there is a 2 kilometer. Bus is required? Not required. Two-wheeler is required. That is called your transport. If you want to go from here to your native, okay, what you will prefer? Bike or bus? Flight? Huh? Bus now. If you want to go from here to UK or US, bus, flight now. That is your transport. Here also, based on your requirement, okay, either TCP transport protocol will come or UDP will come. See, sometimes your requirement in the internet may be web requirement. You can access the google.com now, okay, and mail requirement, sending and receiving the mails, file requirement. Or else if you want to access any remote servers or remote routers, that time, okay, remote access purpose. Okay, these are the requirement only, no? Only these are the major requirements in the internet, okay, by using browser. Correct now? Without browser is possible? No, right? Without browser we can't do these things. Correct now? These requirements, if your requirements are these things, that time which transport protocol will carry? TCP. TCP will carry all these services. TCP is a box. Inside the box, what are the services will be there? These are the services: web service, mail service, file service, and remote access. These are the services we will see inside the transport box is called TCP. Clear now? What are the UDP box consist of what? DNS, DSCP. We will discuss all these things. Don't worry. We have a separate class for these things. IP services. There we'll discuss. What do you mean by DSCP, DNS, okay, and TFTP, SNMP, all these things. All these services will be carried by which box? UDP box. There are two boxes. Comes under which layer? Layer 4. Okay, these two boxes will carry services. Clear now? All these services, okay, we can achieve without browser. Is it possible? With browser is required. Now that means web communication, mail, file, and remote access. We need a browser. Correct now? Browser is works under which layer? Application now. Correct or not? See, we are typing only one thing only in the browser. That is called this. We are typing www.google.com. Correct now? Automatically what will happen? https:// This is a protocol for responsible to fetch the web page. For web communication purpose, there are two protocols. One is HTTP, one is HTTPS. For opening purpose, we're accessing web communication. What are the background protocol? That is called HTTP and HTTPS. Okay, we're accessing sometimes mail communication. That will happen. Background protocol is what? I'm asking background, not transport protocol. Transport is TCP only. New yeah. This guy is Sachin Kumar.
Yes.
This one. Okay, great. Can you please give me the pen? Yeah, come in. Yeah. Let me pause the record for 2 minutes. I need to take the entry and online Ari is there. Can you please tell me your mobile number, Ari?
Yeah, it's 98450
98450
91
91.
069.
You enrolled for CCIE security?
No, just for CCNA.
CCNA. Okay. Ari.
Yeah.
This one. Okay, right. Next, please, physical guys. New. Your name? Hanumantrao. Yes. For which course you enroll?
CCNA routing and
Switching. Okay, CCNA. And mobile number?
630
630
4266
4266
439.
439. Okay, right. Next, please. Next, who is new today? Yeah. Huh? Arvind. For which course?
CCNA
Only. Mobile number? 966 34 97 0 966 34 97 063. Next, please. Okay, you old student, no?
Repeat here.
Repeat. Not repeat. No? Next, this side. All are old. Okay. 19 students are there. Today, only 2 students are new students. You and you. Okay. Bed is pending. Okay. Ari, this one.
Repeat your name.
Okay. Name, please.
Vipin Shukla. Vipin Shukla.
Vipin
Shukla.
Shukla.
Yes, sir.
Okay. Repeat. Okay. For which course you done enrollment? NNP. Yeah. Mobile number?
7879
7879
4455
4455
20.
20. Good. Hari and Mantu and Arvind and repeat. Mail ID also. Guys, yeah. Mail. Hari, can you please tell me your mail ID?
Yeah, sure.
Hari?
Yeah. HARI.
Small, right?
Yeah, all small. Yeah, HARI.
HARI.
Sri, SRI.
SRI.
Peru, that is PERU.
Hari Sri.
Peru, PERU. P as in Peter.
PERU.
Yes, at gmail.com.
Okay, good. Yes, remaining guys, can you please write down your mail IDs? First, Anumant. Yeah. Can you please take pen? Thank you. Let me pause it. Yes, now see. Yeah, what we discuss for transportation purpose at layer 4 UT, TCP, UDP. Okay. Now, what are the background protocol for any services? These are the background protocols. Okay. We are asking google.com how the Google server can able to open that page. Then only we can see here. Because of background protocol is called what? HTTP or HTTPS. Now, for mild communication purpose, there is a background protocol that is called SMTP, and remaining is a POP3, IMAP. Okay, those are for internal message in the Outlook they will use. Okay. Now, for file communication purpose, FTP. See, full forms I'm not telling, you have to write down from internet. For remote access purpose, there are 2 protocols. One is called Telnet. There is no full form for this, and SSH it as a full form. Secure shell. Clear now? These are the background protocols. All these background protocols and all these services works under which layer? Works under layer 7. Works under layer 7, guys. Here. Protocols and services. That means for web service purpose, what protocol is background protocol? That is called HTTP or HTTPS. For mail communication purpose, for mail service, SMTP. For file communication purpose, FTP. For remote access purpose, Telnet or SSH. Clear now? All these services comes under layer 7 only, protocols also. These services, once it will come to the layer 4. Okay, once these services, okay, web service comes under layer 4, automatically enter into which box? TCP box. Okay. Once TCP box, the service will be entered into the TCP box, that is called transport protocol box. Then these boxes will be entered into the one more box at layer 3, that is called IP box. Clear now? IP box. Then this will be entered into the layer 2 box, that is called Ethernet box. That is called what? Ethernet box. Ethernet is a protocol at layer 2. Ethernet is a protocol at layer 2. It will be entered into the Ethernet box. In Ethernet box, every field in the form of bytes. In the form of bytes. Okay. That bytes will be carried by cables. Cables will carry the bytes or bits? Bits, no. That means we have to convert from bytes to bits. Correct now? That will be done by your PC as a LAN card, no? That LAN card will convert, then only cable will carry. This LAN card, what is the duty of this LAN card? This LAN card is converting bytes at layer 2 to bits at layer 1. Then only bits will be carried by this guy, cable. It will come there. Then what this LAN card will do again? This is also LAN card now. It will converting from bits to bytes at layer 2. At layer 2, what field we can see? MAC address. How many bytes MAC address? How many bits? 48 bits in binary. In bytes, 6 bytes. 6 into 8, 48. Clear now? Every field in layer 2 in Ethernet 2 box, every field in bytes, thus should be converted into bits. Sender will do. Receiver is converted from bytes to bits. Sorry, bits to bytes. Clear now? This is all about the today agenda. OSI is done. Now we'll move to the next OSI. Sorry, networking devices. Clear this much or any confusion, any question, ask me. If you will
Sir,
explain more than this in OSI, you will get confused. We will discuss about the OSI remaining also. That is, now today I explain only 20-25% OSI. Remaining 25 to 50% tomorrow. Clear now? Everything is new, right? In the OSA, you can't remember more much if I will explain. Just remember this part, and tomorrow I will ask the questions. Okay, from here onwards we will discuss tomorrow. Now I'm not stopping the class. We will discuss next networking devices. Now
sir,
write down, please. Yeah,
this firewall works on transport layer as well as network layer also, right?
it works under multi-layer device. It works under
Yes.
4, 3, and it works under 2 also. Works under 5 also, 6 also, 7 also, 8 also, 10 also. There are 10 layers will be there. You will understand in the advanced level.
Okay.
Multi-layer device. There is a layer 8 also, user layer. User layer. Layer 9 also. Layer 10 also. Total 10 layers will be there. Okay. Clear, guys? Any question? In the browser, you will type the www.google.com. Automatically, what will happen? Browser is layer 7. Oxygen layer 7 is a major interface between you and your Google servers. Any server in the internet. Now, if you want to access those servers, you type the server name. Automatically, there is a background protocol will be enabled. That is called HTTP or HTTPS at layer 7. That layer 7 protocol, once it will come to the layer 4, it will be entered to the layer 4 protocol box. That is called TCP or UDP. Suppose your requirement is DNS. That DNS will be entered to the which box? DNS also layer 7 only. All are what works under layer 7 only. All are services works under layer 7. That DNS service will be entered into the UDP box. Correct now? Then these two boxes will be carried by IP box. This IP box will be entered into the Ethernet box. In Ethernet box, every field in bytes that should be converted into bits. Then only bits will be carried by your cable. Clear now? This is a basic understanding. Okay, and tomorrow we'll discuss remaining also. Now, how much you understand? Okay, can you please write down? See guys, these are the networking devices. You know about the LAN card or NIC card? This is your LAN card, NIC cards. Okay, and this is about the cables. These two are what? UTP cables. This is called what? Dish TV cable or coaxial cable, and this is called what? Fiber optic cables. You know, yes. Now, first device is called hop. Next one is called bridge. Next one is called switch. Next is router. These are the devices. Okay, these are the networking devices. We'll see now. Now write down hub. These are the points. Okay, hub is a which layer device? Layer 1. Okay, it will do always what? Broadcasting. Okay, what about switch will do? Switch will do, it will do, see, it will do first time broadcast. Why it will do first time broadcast? Because of we don't know about the destination MAC address. That's why it will do broadcast. And next time onwards, unicast. But hub is not like that. Always broadcast. And due to broadcast, what will happen? Unnecessary traffic will be carried via cable. There is a unnecessary bandwidth utilization. Okay, the performance may go down. What about the switch? Good performance. Because of it will do next time onwards unicast. No need to send to all the ports. Okay, and good performance. It works with the full duplex. What about the hub? Half duplex. Correct now. See, hub is a works with the half duplex. What about switch? Full duplex. Difference between half duplex and full duplex? Half duplex means at a time one device either you can send or receive only via particular hub port. What about in the switch? Via this port I can send also, I can receive also. I can send the data to the multiple users and also I can receive from multiple PCs. That is called full duplex. That is called what? Full duplex. Next point. Yeah, it has one broadcast domain, one collision domain. Just to remember, broadcast domain 1, collision domain 1. What about in the switch? One broadcast domain and multiple collision domains. Okay, just to remember. Okay, I will explain that. Now, here it doesn't have any OS. iOS means inter-networking operating system. No OS means that is not intelligent. Na? Correct. Now, what about in the switch? It has a iOS. OS will be there. And also it has a memory also, but hub doesn't have any memory. No memory. Okay. There is no buffer. Okay. What about here? There is no buffer. What about switch? It has a buffer. Memory. Okay. That's why it is intelligent. What about this? It's not intelligent. Okay. Next, in the switch. See, it will store the MAC address entries of all the PCs now. Via port number 1 who is connected, via port number 2 who is connected. All the MAC address your switch will learn and it will stored in the one table. That table is called what? MAC table. Clear now? Once your MAC address entries will be learned automatically, we are not adding anything in the MAC table. That will be automatically will happen. Okay, by means of ARP request and reply. How the ARP request and reply will happen, that we'll see tomorrow. Don't worry. Okay. Now, automatically, your switch will learn all the PC's MAC address dynamically. That entries will store up to 5 minutes. See, once switch will learn all the PC's MAC address via port number 1, your MAC address, 2, your MAC address. Okay, it will store all the entries in the MAC table. Okay, that entries will be there up to 5 minutes. If you all guys shut down the laptop up to 5 minutes, then switch will do what? There is no traffic is coming from any PC. Let me erase all the entries. After 5 minutes. Clear now? That means that is a lifetime MAC aging time for the switch. That is called what? 5 minutes in the seconds? 300 seconds. Okay. This is the difference, guys. Now write down first. How? Get it? We can do only via particular port. We can send or receive only one task only. Suppose there are PCs order. Let me draw now. Yeah, this MAC address is A, this one is B, and this one is what? C. Clear now? Now, first communication will happen from 1 to 2, 1.1 to 1.2. That means A to B. This is the requirement. Okay, this requirement will be okay. Okay, one-to-one communication will happen. Okay, one-to-one communication will happen. Now requirement will be changed. 1.1 want to communicate with the 1.2. At the same time, 1.2 also want to, sorry, 1.3 want to communicate with the 1.1. Is it possible? At the same time, not possible, no? That time what will happen? Once packet will reach to the hub port. Okay, it is sending. At the same time, 1.3 also sending to 1.1. What will happen? Via particular port, either you can send or receive only one task. Here what happened? Dual task now. Then what will happen? There is a collision. Collision will occur, guys. Once collision means accident will occur, that collision will be affected for all the ports. Remaining all the guys also could not send and receive the data. Once collision will happen on any port, that collision will be applicable for all the ports, all the hub ports. That means once collision will, only one collision domain is there. But in the switch, that collision, once collision will occur, that will be applicable for everybody, all the ports. That now in the switch, what will happen? Suppose the collisions will not occur here. Suppose collision will be occurred on this port. Okay, the only that port which device is connected, only that device only could not send and receive the data. Only that device only isolated from the network. Whatever remaining ports, still they can send and receive. That means here is for every port as a separate collision domain. If the collision will happen here, only that port only disturb, not remaining ports. If the collision will be occurred on this port, only that port only disturb, not other port. Clear now? That means how many ports are there? That many collision domains will be there. The collision domain is permitted only for that port only. It will not disturb to remaining ports. How many ports are there here? 3 now. That means how many collision domains? 3 collision domains. What about in the hub? Once collision will occur, no, that is applicable for all the ports. That means only one collision domain. Okay. What about the router? Router also same. We have a router here from day to switch to PCs, from day to switch to PCs. How many ports are there here? This one and this one. No? 2 ports are there. Every port has a separate collision domain. That collision, suppose collision will happen on this port, it will not affect to that port. That means how many collision domains here? 2 collision domains. Understand? No? In the hub, how many collision domains? In the hub, only one collision domain. In the switch, multiple collision domains based on the ports. In the router also same, na? Based on the ports. Okay, here is one collision domain. Here is multiple collision domains. Here is what? Multiple collision domains. What do you mean by broadcast domain? Broadcast domain means switch also will do first time broadcast. Received on port number 1, sending on the port number 2, 3, 4, 5, 6. That means this guy is sending, remaining all guys are receiving. Okay, that means one-to-all communication is happening. That is happen in this area. That area is called domain. Area is called what? The broadcast is happen up to this much area. The area is called what? Domain. The broadcast is happen in this area. The broadcast is happen in this area. That is called broadcast domain. That means here also one broadcast initially. What about the hub also? Anyway, it will do broadcast. That means there also one broadcast domain in switch also only one broadcast domain. Here understand one thing, broadcast domain means equivalent to network. One broadcast domain equal to one network or one department. Can I connect the multiple departments by using switch? Multiple networks. Can I connect? No. Router is required now. That means by using router, I can able to connect the multiple networks based on the multiple ports. That means how many? Here is one broadcast domain is only one network only I can able to connect by using switch. What about here? Multiple networks. That means multiple broadcast domains are possible. Multiple broadcast domains, multiple networks I can able to connect. Every network there is a broadcast will happen. Clear now? Clear about this one? Broadcast domain and collision domain. Broadcast means one to all. That one to all means how much distance, how much area the broadcast is happen. That area is called domain. In a particular domain, the broadcast is a broadcast means one user is sending, remaining all guys are receiving. Remaining all the PCs are receiving. Okay, that is called broadcast. That happen in particular. How far? That is called distance now domain. Clear? This one write down, guys. At one line, at one place, you will get all these things. In the hub, one broadcast domain and one collision domain. Okay. In the switch, multiple collision domains and only one broadcast domain. In the router, multiple collision domains and multiple broadcast domains. Written? No.
So one question.
Yeah.
Regarding this being for 1.1 to 1.2, at that time the switch will broadcast. Now there are different levels like 1.3 and 1.4. So the next time when the 1.1 picks 1.3 again to broadcast or it will
Broadcast.
broadcast. So whoever receives then that only that MAC address will be stored.
Yeah, yeah. There is no entry in the MAC table, it will do broadcast only. The PC is generating the broadcast, that is called ARP now, that is also broadcast. Switch will do broadcast. The PC is sending the ARP packet now, that is broadcast actually. That time broadcast switch will do. And if that we have a entry, there is no ARP packet. Switch is not, PC is not sending ARP packet. Switch PC is sending original packet. In that source and destination MAC address are there, but destination MAC address is not there in the MAC table. Then switch will do broadcast. There is no entry in the MAC table, it will do broadcast. There, if the PC is sending the ARP now, that is called broadcast. That time switch will do broadcast. We will discuss that ARP resolution, everything tomorrow. Now, see guys, what do you mean by broadcast? Broadcast means one message will travel one to all now in a specific area, that is called domain. Specific area, that is called what? Domain. Okay. Clear? Right. Collision domain means once collision will occur, that collision will be applicable for all the ports in the hub. Whatever in the switch, that collision will be applicable only for that port only, not for remaining ports. Okay. Now, what do you mean by ARP protocol? What ARP protocol will do? ARP means address resolution protocol. ARP will discover the destination MAC address with the help of destination. I know the destination IP 1.2, but I don't know MAC address. In that time, who will figure out the destination MAC address with the help of ARP protocol? Okay, write down this. At this one, don't write, you will get confused. Only broadcast amendment. Yeah, you can write on that. This also no problem. By a particular port, we can send also, receive also, no. In the switch port. Why written like a one logical path? Here, guys, I written like a only one logical path. Now, what do you mean by one logical path? Hub is a layer one device, no cable, na. That means internally, okay, we have ports. Externally, ports will be there, but internally, all these ports are connected with the one cable only. Only one path is only one cable is there. Why that cable? If multi users are sending and receiving, what will happen? Collision will occur. That collision will be applicable for everybody. Clear now? Hub means internally all the ports are connected with the one cable only. That is called copper media cable. Copper cable only. Okay. Only one path is available. In the switch, what will happen? In the switch, okay, they can able to create the logical paths. From here to here also separately one more logical path. Here to here also. Okay. Okay, if any one path is corrupted, no issue. These two guys will communicate. Suppose this path is corrupted, then what will happen? It will send to this guy and this guy to this guy. One more path is there now. They will communicate. That means multiple logical paths will be created by switch with the help of switch virtual circuit. For the concept, switch virtual circuits. These are nothing but a switch virtual circuits. Multiple like a ring road. Okay, there is a narrow road. What will happen? In that narrow road, only two guys will go. One guy is this direction, one guy is this direction. Suppose one more guy will come, what will happen? Accident. Okay. Once accident will happen here, then remaining vehicles will be there now here. Correct or not? These vehicles should stop particular time up to clearing that accident. Correct now? Same will happen in the hub also. All the pieces should stop the communication at a particular time period. That time period has been given by the one algorithm that is called back off algorithm. Which algorithm? Back off algorithm. Back off algorithm will define some timers for clearing that job once accident will occur. That means once collision will occur. Now, for clearing that collision, there is some time is required. That time has been declared by algorithm. That algorithm is called what? Back off algorithm. That timer is called backup timer. Once backup timer reached 0, that means timer is done. Then remaining all the guys, they can send and receive the packets in the hub. I'm talking. Same now, once to clear this accident, then only these vehicles can move now. Correct or not? Okay. What about we have a ring road? This is not a narrow road. We have a ring road. Is there? Okay. So many paths are there. So many paths. They can go different path. Na? That is possible in the switch. Okay. Logical paths are available. In the hub, no, only one path is there. If once that path is corrupted, then remaining all the guys should wait for a certain period of time to clear that job. Clear now? That timer is called what? Back off timer. Which algorithm has defined that timer? Back off algorithm. Clear now? Now we have a one mechanism CSMA/CD. Carrier sense multiple access for collision detection. Carrier sense multiple access for collision detection to overcome these collisions. Okay, to overcome these collisions. Before occurring these collisions, okay, we need to see after occurring the collision, we can't do anything. No, we have to wait for certain period of time. Okay, that will be given by the algorithm, backup algorithm. Now, before occurring the collision, we need to detect the collisions. We need to overcome that collision. Okay, that will be happen with the help of this technology. How this technology works? Let me write down that. CSMA/CD. Say guys, this is called cable, right? This is called cable means up also layer 1. No, this is not good. This is called hub. This is called what? Sorry, not this one. Yeah, this one. Hub. Okay. Now I'm connected some PCs over there. I'm connected one some PCs now. PC number 1. One more, and one more. All these guys are connected with the ports only now. They have their own ports here. They connected here. And this is called port number 1. 1, 2, 3, 4. Okay, or else 1, 2, 3, 4. Okay, 1, 2, 3, and 4. Okay, and this MAC address is A, B, C, D. IP address 1.1, 2, 1.3, 1.4. This is called what? Cable I written. That means hub only. See, hub internally what will be there? All ports are connected with the one cable now. That's why written like a cable. Now here your hub works with the what technology? Hub duplex. Hub duplex means only one guy can send the data on a particular PC. But he is sending the data at the same time. One more guy also sending. That means he received now. That is possible? Not possible. That means it works with the hub duplex. Now see here, this is a requirement. 1.1, 1.2 want to communicate. Okay, RS 1.4. And 1.2 want to communicate with the 1.3. This is the requirement. Is it possible? Possible or not? Not possible. Okay, suppose this is the requirement. What will happen? Once packet will be received by the hub port, it is processing at the same time. Okay, it's processing at the same time. 1.2 also sending now. Packet will come there. He's also processing. Both guys are processing. What will happen? To overcome this collision, to minimize these collisions, we have a technology that is called what? We have a CSMA/CD is a protocol. CSMA/CD. Okay. C means what? Carrier. C means what? Carrier. S means sense. M means multiple. A means access. CD means collision detection. See, these things are not there nowadays, new CCN. Okay, whatever I'm explaining now, maximum things are not there. Simply I'm explaining for your knowledge purpose. See guys, carrier sense. See, carrier sense. See, this is a road. See guys, if I want to reach from, if anybody want to reach from this side to that side, what we'll do? Once we will come there and we'll see this side and this side now. Then only we'll cross. Because this road is not for you, for everybody. Everybody should sense the road. Then only we can safely reach to that side. Suppose blindly if you are going, what will happen? Accident will happen. That's why that means before once a packet will come, this is path for everybody. Okay, before processing, before sending, you have to sense this media. Sense means monitor. Anybody is processing this media or not? Yes, nobody is processing, then I will continue. Correct now? At the same time, a requirement is coming from 1.2 also. And you will also sense the media now. Anybody is processing? No. Processing. You will stop the is communication. Okay. Once this communication is done, then only you will sense. Anybody is processing? No. Nobody is using that media. Then I will proceed. Then I will proceed. Any collision? That is all about the CSMS/CD. Sense the carrier. Carrier means media. Before processing any request, sense the media. Because of multiple users, access means multiple users are accessing this media. Okay, this is for everybody. Okay, before accessing this one, you have to sense that media. Nobody is processing, then you can continue with the process. Okay, for what purpose? To detect the collisions and to avoid the collisions also. Clear now? With the help of days, even though there is some delay will be there. While communication is, see, once communication is done from way to way, from here to here, once communication process is done, then only this communication will happen. Anyway, there is some latency is there, no issue without any collision. Clear now? Without any collisions. Clear now? This is all about the CSMS/CD will be useful in this scenario. That is a inbuilt. Okay, that is a inbuilt. But nowadays we are not using any hubs. Just scenario how it can able to minimize the collisions. Okay, how it can minimize before occurring any collision. Clear? This is all about the CSMA/CD, and time is almost 10 o'clock. Clear, guys? And this part we'll see tomorrow. And not only this, we'll discuss about how many collision domains are there here in this different topologies. Okay, we'll see. Okay, how many collision domains and how many broadcast domains will be possible. Else we'll see now this. We'll complete tomorrow. See guys, this is called this symbol is there now. This is called hub only. Multi arrows are there now. Switch. Only one arrow now. This is called hub. This is called router. Now we'll see here how many collision domains and how many broadcast domains. How many collision? First, how many broadcast domains and how many collision domains? See guys, this guy is sending this hub will forward to everybody. That means one broadcast domain. Hub means one broadcast and one collision. That's all. What about here? How many broadcast domains? How many collision domains? This guy is sending now. And this hub will forward via this port, and this switch also will forward to everybody now. That means one broadcast domain. How many collision domains are there? In the hub, we have only one collision. That means this total part is one collision domain. What about here? Second collision domain, third, fourth, 5. Total how many? 5 collision domains. Clear now? Switch as a multi collisions. How many ports are there? That many collision domains. Okay. Now, bridge also same like a L2 device. Switch only. Here is hub is there. It will do broadcast. Bridge is there. It will do broadcast. Same like a switch. That means one broadcast domain. How many collision domains? This is totally one broadcast, and here, sorry, this is totally hub means one broadcast, one collision domain. One collision domain. What about here? This is L2 device, same like a switch. How many ports are there? 2 ports. That means 2 plus 2, 4 collision domains in this topology. In this scenario, this is 1, 2, 3, 4. How many collision domains? 4 collision domains. How many broadcast domains? See, broadcast domains are important. 4 collision domains are there. Broadcast domains. This guy is sending this guy will forward via this port and router will not forward the broadcast from one port to another port. Router will not forward the broadcast. That means it will stop there only. This is called one broadcast. And this guy is sending. This port will forward. This router will forward to other port? No. This is one more broadcast. This guy is sending. Forward via this port. It will come there. This router will forward to other port? No. That broadcast will not forward. That means how many broadcast domains? That means you understand how many ports are there? 3 ports. That means how many networks I can connect? 3 networks. That means 3 broadcast domains. 1 broadcast, second and third. Clear now? Yeah, number of ports. Okay. Clear, guys? This is all about the how to calculate the broadcast. Sorry, how many broadcast domains are there and how many collision domains are there. Okay. And we'll see tomorrow also that one by using this topology. Which topology? Next topology. This is mixing. Here, how many broadcast domains will be there and how many collision domains will be there, that we'll discuss tomorrow. Okay. And also remaining stuff also we'll discuss. Any question up to here? And then guys, any question? Dipin and Ari?
No, sir, all clear.
Clear? Huh? Right. What we discussed today? Today we discuss about the what are the components are required to form the network. Your LAN card has a 2 addresses, MAC address and IP address. MAC address is all about the how many bits in hexadecimal, how many hexa numbers. Then we discuss about the what are the components will be there, and sorry, once you design the network, what are the things you need to check whether secure communication is happening from client to the server, and also whatever the servers are available or not, that is called availability, and also who can able to access the servers, that is called what? Confidentiality, integrity and availability. How many types of networks are there? LAN within the building, CAN, MAN and WAN. Next, what we discuss? Forget, huh? Types of cables. Next, we discuss about the types of cables. Under copper media, 2 cables. One is dish TV cable. One is called what? LAN cable. Under fiber optic, multi-mode and single mode, there is some distance support will be supported by in the multicast only 2 kilometer. Sorry, not multicast, multi-mode, and a single mode only 40 kilometer. What are the connectors we discuss? Then we discuss about the types of communications and modes of communications. Then we discuss about a little bit about the OSI. Then networking devices. The router pending is there, that we'll see tomorrow. Okay. Okay, tomorrow we'll discuss. Okay, OSI for 25 minutes, then router for 10 minutes. Then we'll discuss about the packet flow. That is it now. Day 2 is what? Packet flow. How the packet flow will happen. Clear, guys? This is all about the today agenda done. And tomorrow we'll discuss remaining topic. Okay. Any question? No question? Right. Ari?
None for now. Sure.
No question. Right. Dipin, do you have any question?
No, sir.
No question? Right. Okay, guys. See you tomorrow. Okay. Take care.
Okay.
And I will ask the questions also tomorrow. You need to write down all the